Well, thanks everyone for coming. I appreciate all the customers and investors and analysts and friends of Amprius, suppliers as well. I want to echo Kang's comments. This is an auspicious beginning for us. It's an expansion that was long in planning and short in coming. We did a lot of work to make this happen, and now we're going to execute to make money. Let's see, where do I start with do I just flip through this? You know, this is our tagline, transforming electric mobility. Our focus today is on aviation. It plays to our strengths. It plays in our wheelhouse as a high-performance silicon anode-based lithium-ion cell. We started out in 2008 with an idea, and that idea was transformational, and now it's reality. It's been reality. When in 2014, we finalized the design of unique and ideal, it turns out, silicon anode. And it's ideal for commercial applications that we have enjoyed since 2018. And that was enabled by kilowatt-hour scale manufacturing that we brought to the pilot operation in 2016. So we've been doing this now for quite a number of years, and as a result, we have a commercial footprint that's critical, and we're very fortunate to have tier one and outstanding customers who have been pulling us along. In fact, that first product was with Airbus. Airbus is here today. They'll be presenting the case for their product, which is enabled by our lithium-ion cell performance. In the meantime, we've been continuing to expand our performance. We have an extreme fast charge capability, also very high discharge capability, 0 to 80% in 6 minutes. That's unprecedented in terms of extreme fast charge. We're shipping today a 450 watt-hour per kilogram cell. That's unprecedented in this space. And last year, we had a pretty important event at the New York Stock Exchange. And that's enabled us to move into the adjacent facility and expand by a factor of 10. What we're talking about today is what we're doing in that expansion facility. That's megawatt-hour scale manufacturing, which is the foundation for mass production. We're also continuing to expand our portfolio. Our next product out is a 500 watt-hour per kilogram cell. We've already published on that with third-party validation, and that's going to continue to push the envelope on performance for our aviation customers. A little on background. So, you know, we're known as the pioneer for silicon anodes. And I guess the question that you might be thinking or asking is, what's so important about silicon? Why silicon? So if you look at this bar chart, it sort of gives you the answer. Compared to graphite, which is the incumbent anode material, graphite is a form of carbon, it has 10 times the capacity. So pound for pound, you have 10 times more effective energy in silicon compared to graphite. That's the fundamental reason why silicon is so important. It has about the same raw material cost as graphite today, and you can make much smaller anodes, thinner, lighter. What about its abundance? It's the second most abundant element on Earth. So there's no shortage of silicon. And if we compare it to carbon, which is the incumbent anode material, it's 1,000 times more abundant. Or lithium, which we all know about, it's 10,000 times more abundant. So silicon isn't something that we have to think about as a strategic mineral. It's something that we can extract from sand pretty readily. And what about the performance that it enables in products? Products are where you make money at the end of the day and where you can continue to expand your market. So the products that we've demonstrated are, for example, in aviation. For a drone, we can double the flight time. We have an example today of a product that we've doubled the flight time for. In military applications, military battery packs, we can double the mission time. That's super important to the warfighters today to have that mission capability. And we've simulated for an EV, in this case a Model 3, that we can double the range. So this opens new doors for electric mobility. And by having such high energy density, we can double flight time, we can double range, and in addition, because of extreme fast charge, we can turn around those aircraft very quickly and make a business case that makes commercial sense or gives tactical advantage to certain applications. So, you know, this is what people are suffering from right now. And we're going to change that paradigm with our product. So we enable the highest performance cells for mobility, and what's shown here are customers we're presently serving. High-altitude drones, reconnaissance drones, drones of any kind, frankly, and we're now moving into eVTOL. eVTOL, of course, are the flying cars, urban air mobility, that are literally taking off as we speak, but they're limited by batteries. Batteries are the bottleneck, if you will, for enabling this real commercial market. So customers are expanding, and the demand is expanding. And here's a short list of tier ones that we're presently serving. This is why it's so important for us to expand to meet that demand. And megawatt hour is the first step toward mass production. It establishes the sort of foundation of mass production, and that's what we're doing in this facility, and that's why you're here to help us celebrate. So how do we do mass production? What's going on in that adjacent facility? So it's important to communicate that we change one thing. We change the anode. The rest of the manufacturing line is fully derivative of the global supply chain. All of the equipment, the bill of materials, they're all right off the shelf that everyone else uses. So we don't have to reinvent the wheel on the assembly of a lithium-ion cell. So for example, in the cathode line, that's off the shelf. In the assembly operation, we use stacking. That's ideally off the shelf, and in formation, which is the first charge-discharge cycle, that's off the shelf. What isn't off the shelf per se is the silicon anode. However, we're adopting a platform, and my colleague at Centrotherm will discuss his company and the support that they're giving us, is unique in the application for silicon anode. It's a new channel for the Centrotherm, and what does it enable? It enables high-performance cells. So I have here today a cell in my pocket that is an example of what we're producing. So this is a cell for a first demonstration for urban air mobility. This is what we've identified as and published as a 400 watt-hour per kilogram cell with 10C capability. You can see the tabs are beefy. It passes a lot of power. It also enables high rates of charge. And what about the manufacturing of that silicon anode? How is that done? So as I said, Centrotherm is the platform that we've adopted. Why have we adopted the Centrotherm platform? The mission is to leverage existing commodity manufacturing platforms that are already proven in production. So we don't have to reinvent the wheel on the fundamental infrastructure. We just have to adapt it for our application. So it's adopt, adapt, and then scale. Scale means basically wash, rinse, repeat. Proliferate a factory with that equipment. And what's the underlying process inside that tool? It's chemical vapor deposition, which is a standard process used in many industries, solar, for example, the semiconductor industry, other kinds of deposition applications. And the precursor, or the feedstock gas, is silane. That's basically silicon with 4 hydrogens, mostly silicon. And it's a direct-to-electrode conversion. We take the silane gas and directly convert it into an anode. We skip the intermediate steps that conventional processes use. And let me illustrate it here. For graphite, you start with graphite powder, which is derived either naturally by mining or synthetically. Then you mix it into a powder with other ingredients, binders, conductive agents, solvents, slurry coat it, dry it, press it, and then send it on its way into assembly. In the case of silicon composites, similar, except that you have to take that silane, convert it into some kind of powder, whether it's pure silicon or an oxide of silicon, blend it with the rest of the ingredients, and then follow through all of these sequential steps. In our case, it's CVD direct to the electrode. So we skip all these intermediate steps. And that means that we have a continuous process, what I like to say, bare foil in, finished anode out. So what about that process? We start by growing a nanowire direct from the current collector. That's a template. It serves as the backbone for the subsequent silicon deposition. It's electrically connected directly to the current collector, so it's electrically continuous. It's metallurgically connected to the current collector, so it has a high integrity physical bond. And then we coat it with silicon. And this coating is, of course, the material that is the means by which we move lithium in and out. This is a cross-section of an actual anode. This is a top-down view coming out of this high-throughput system, the centrotherm system. After that, it's essentially generic. We use a laser for cutting the form factor. This allows flexibility in the shape that we can employ for various customers, various applications, various cell models. Then it goes into stacking. Stacking is essentially pairing the electrodes with a separator in between. Again, this should be an off-the-shelf system. And then we insert it in a pouch and seal it. And then that takes it to the next step, which is electrolyte injection, again, off the shelf for inserting the medium through which the ions flow, formation, which is the first charge-discharge cycle, followed by inspection, and then it's ready to ship to our customers. So let me summarize here. This is a megawatt-hour scale facility that we're now going to execute the process steps that I just outlined. For breakthrough performance, 450 shipping today, later next year 500 watt-hours per kilogram, based on a silicon anode with performance that is untouched by competition in this space. We have a very significant IP portfolio that protects everything that I just talked about. And we have a large and growing customer base with many SKUs that support our customers. Here's a short list of these customers that have validated our technology. It's growing, and we continue to support them, and we appreciate that they're continuing to demand more from us. I want to just acknowledge a few people. Aaron Backey, our VP of Operations, who was a critical partner in crime in the design of the adjacent facility. Lance Seipen, our facilities manager, who managed the execution. And I'd also like to thank our general contractor, Technical Builders, of whom Tom Ricketts was the leader of that. So thank you for your support. And thank everyone for coming today. Okay, I'm going to introduce our next speaker, Dr. Helge Haverkamp. Dr. Haverkamp is the Chief Technical Officer of Centrotherm. He's also directing operations. So he's got a huge portfolio. I want to also take this opportunity to thank Helge for all the support over the last several years that you've given us, much of it for free. They see a new market, they see an opportunity to expand, and we're the footprint that they're hoping to establish. So thank you, Helge, and without further ado.